So you've done some research on where the term robot comes from, some history, as well as where we think we're going in the future, and we've talked a little bit about that. Now let's go into some of the details that are more specific to what we're going to be learning in this course to help you also gain a better understanding of where are we currently in robotics and where are we going to be going in robotics and why should you take this course in the first place. So first thing we need to look at is what is robotics? Well, the term robot comes from the Czech language and is coined by Karl Kopek in the play Rossum's Universal Robots, or RUR, which was written in the 1920s. So that's actually a fairly recent term. It's not something that's been around for ages and ages and ages. And even in that sense, it's not what we typically would think it is. It actually has two root words in the Czech language, robota, which means compulsory labor, or robotnik, or a peasant owing compulsory labor. So the actual concept of the term robot is I get someone to do something for me. And that is very true in the sense that when we start trying to develop a definition for robot or robotics, is that we see that robotics in general tends to try to solve a problem or have us do something that we typically don't want to do, whether it's vacuum our house, in which case a Roomba can help you out there, or whether it's diffusing dangerous bombs or IEDs, in which case we have robots that do that. So the concept behind robots is very rooted in the definition or the term robot, which comes from, once again, the Czech language, and it was coined in that place. So if that's the case, then what is a robot? And if you actually did the research, you would see, and you probably saw this as you went through and tried to find different definitions, there's actually a number of different definitions for the term robot. And some can encompass things as simple as a programmable toaster, all the way to things like the Honda Asimo and completely autonomous robots. So for the entirety of this course, we're going to define the term robot in basically having or meeting four criteria. A is a mechanical device, meaning that it is made up of some mechanical components or physical components that have it operate to do something. It's programmable, meaning that I can change the functions or things that it does, the primary things that it's supposed to be performing, in order to make sure that it does exactly what I need it to do. It has to carry out a set of instructions. So it can't just be I press the button and it does something. It has to have a set of instructions, a group of instructions that it carries out step by step in some type of logical procedure or order. And it performs a task usually done by people, or attempted by people, or maybe a task that people can't do but would like to be able to do. So that expands this into a number of different things. So keeping those four things in mind, it's a mechanical device, it's programmable, it carries out a set of instructions, and performs tasks usually done by people, we can kind of start to narrow down what we're talking about when we look at what a robot is. Now you may say, well, that sounds a lot like a computer. A computer has an input and output, it carries out a set of instructions, it's a mechanical device, although it also has electronics as well. It meets all those criteria that we just discussed. So what is the difference between a computer and a robot? What we'll see is that computers don't perform physical tasks. That's one of the main things that we looked at, is that it can perform tasks that a human would want to do. Well, in this case, can a computer perform complex mathematical calculations? Absolutely. But typically when we think of robots, we think of them performing some physical tasks. That's why one of the criteria was a mechanical device, not necessarily just an electronic device. So what we will see with a number of different robots is that they will typically contain at least some type of computer or an advanced computer, or is controlled by a computer in some ways. For example, the Roomba would probably meet some of that criteria and is controlled by a specially designed robot that controls it. So let's look at some examples. So what can we say is and isn't a robot? We're going to look at a few different examples. I want you to think to yourself, what will each of these be? What does it meet those four criteria that we talked about? And would we consider this a robot? So once again, mechanical device, programmable, carries out a set of instructions, and performs a task usually done by people or desired to be done by people. So first thing, your standard vacuum cleaner. What do you think? Does it meet the four criteria that we talked about? I'm going to give you a second, and then we're going to go over the criteria. Okay, so is it a mechanical device? Absolutely. Does it perform tasks done by a human person? Yes, it does. Does it carry out a set of instructions? Not really. It's got a button that turns it on and off, and also it doesn't really meet the criteria of being programmable either. So in that sense, it's not really a robot, this particular vacuum cleaner. Now, let's move here. A Roomba. Some of you may be familiar with these little devices that go around the ground and will vacuum your house, and some of them actually clean floors and so on. So is this Roomba a robot? Well, let's look at it. Is it a mechanical device? Yes. Like our vacuum cleaner, it is a mechanical device. Is it programmable? Yes. You can actually have it set to a number of different settings, depending on the size of the house, the size of the rooms, how dirty the floors are, and so on. Does it carry out a set of instructions? Yes, it actually carries out a very complex set of instructions and an algorithm that it uses to calculate the most efficient way of cleaning the house. And is it something that a person would typically do? Well, yes. And the nice thing is it does it for us. Once again, kind of giving us that idea of a robot. So Roomba, definitely chalking that one up to the robot column. Now notice that the previous vacuum cleaner that we talked about was not a robot, but the Roomba was, and it had those two primary components, programmable and follows a set of instructions, that made it unique in the terms of the concept of our vacuum cleaner. So the next thing we have here is a toaster. So is this toaster that we see here a robot? Well, let's look at it. Is it a mechanical device? Yes. Does it perform tasks that people would typically do? Well, yes, you could hold a piece of toast over a fire, although this is a much more efficient and easier way of doing it. Is it programmable? Well, this particular toaster oven doesn't look like it. You may have some things where you can set the temperature, but that's kind of iffy. Does it carry out a set of instructions? Not really. It's basically slide it down and the time goes. So in this particular example, the toaster oven would probably not be considered a robot. Now, what if we had a toaster oven that had a number of different presets and different darkness levels and calculated the time that it would take to toast different types of breads and those kind of things? Then you're talking about a robot because it's programmable and it's carrying out various sets of instructions based on the different types of toast. So could this toaster be converted to a robot? Actually pretty easily, and you may see some more expensive toasters that do that. Alarm clock, a very simple device. Most of us have one in our bedroom. Is an alarm clock a robot? So let's think about it. Is it a mechanical device? Yes, it is. It's actually an electrical mechanical device. Does it perform a set of instructions? Yes, it does. It has a time set of instructions that's keeping track of, as well as the different alarm settings that you may have. Is it programmable? Well, yes, I can set different times I want to wake me up, and I can also set the time zones, daylight savings, all these things. However, does it perform a task typically done by humans? Well, let's think about that. Who wakes you up in the morning if you don't have an alarm clock? Well, the sun may if you oversleep, or if you remember when you're in high school or middle school, your parents may have come in screaming and yelling and trying to kick you out of the bed. So does this perform a task that is usually done by humans? Absolutely. So in this definition, although it's kind of a loose way of looking at it, this alarm clock, because it's programmable, because it carries out a set of instructions, and because it's a mechanical device, and it does a task a human would do, is considered a robot by the means of our definition, albeit a very simple one. Now, microwave. Similar concept. Is it a mechanical device? Yes. Does it perform a task humans would usually do? Yes. It cooks food. Is it programmable? Most microwaves will have a number of different presets, which are different programs that it runs, which are sets of instructions, and you can change the amount of time that it does. You can set cooking weights and all those kind of things, even with your simpler microwaves. So we're going to chalk this one up as well, similar to the alarm clock, that this is, under our definition, a robot. Now here we have a laptop. What do we think? Is a laptop a robot? Well, based on what we talked about earlier, it doesn't really perform a physical task, unlike our alarm clock, which actually wakes somebody up, unlike our microwave, which cooks food, and even our toaster, if it is programmable, cooks food as well. So it doesn't perform those physical tasks, and thus we don't consider it a robot. But keep in mind, laptops, computers, those kind of things are integral parts of developing a robot in many cases. And here we have a standard household refrigerator. Well, is it a mechanical device? Yes. Is it performing physical tasks, cooling the food? Absolutely. Something that we want to be able to do. And is it programmable? Some are, some aren't. Just depends on if you have different settings between the different sides, whether it's hotter or colder, if you have different ice settings, if you can program it to have different times of the day where it's warmer or colder, defrost settings, all those kind of things, depending on essentially whether or not it's got a computer built into it to have those settings available to you, would determine whether this refrigerator is a robot. This standard kind of refrigerator is mainly just buttons and pushing things, so we're going to say that that one is not going to fall into that category. Now, programmable thermostat. This is kind of an interesting one. Does it perform a physical task? Well, let's come back to that. Is it programmable? Yes. Does it carry out a set of instructions? Yes. Does it do something that we want humans to do? Yes, it actually tells our heater to turn on and off. So, but the question becomes, is it performing a physical task? Well, let's think about it. Your thermostat, when it detects that there's a temperature that's too low, it's detecting a temperature, is then going to send an electrical current to your heater to tell it to kick on so that it heats your house. So when paired with a heating unit, it actually does perform a physical task, either heating or cooling your house. So in that sense, we would say that this is kind of the brain of our heating and air system, which is a robot. So those are a number of examples of the robots that we can see. So how far back do robots go? Well, think about our natural instincts. How far back have we wanted other people to do our jobs for us? You may not initially think when we talk about BC, before Christ, well, yeah, that's a long time ago, but did they really have robots back then? Well, like we said, the concept of having other people do stuff for us dates back as long as humans have been around. So what did robots look like back then? Well, a lot of times we'd see kind of very simplistic inventions. There were the Greek myths of Hephaestus and Pygmalion. There are the Egyptian oracles or statues with priests in them. Those were very popular, especially to get an inanimate object to look like it was reacting to people or listening to prayers and then speaking to them. The Babylonian water clock clepsydra may have been something that you saw. It was actually a clock that when you ran water through it would keep time. It had a number of complex gears, so very simple precursor to that alarm clock that we talked about earlier. Even in Homer's Iliad, he mentions a thing called automatae, which are devices that would do things for them. And in Plato's Phaedo, he talks about human thought in relation to mechanics. So once again, taking human thought and applying it to a physical object and having it do things for us. So Homer talks about wanting to have these things that would do work for us. Plato says that, hey, what could happen if we applied human thought to mechanical devices? Wouldn't that be nice? Wouldn't that make life a lot easier? So even in BC, we're seeing that initial step towards what we would consider a robot. While these may not necessarily fit our definition, they're leading towards that ultimate goal. It's just the technology is not quite there to get us over that threshold to the true definition of what a robot is. Some other things. Archias of Tarentum builds a steam-powered pigeon. Basically, it would heat the steam. It would make the pigeon flap its wings and make noises and those kind of things. So a mechanical device similar to the water clock and how it operates, but it's powered. It's programmed in a sense because it performs specific functions based on how much pressure there is. And it does a number of different things that some of our simpler toys would even do, but in their idea, this was a very complex thing. Aristotle during this time also mused about tools working for themselves. What if a hammer could pick up and hammer for itself? And so going back to some of our philosophers were even talking about this concept of having inanimate objects do things for us. The Chinese developed a mechanical orchestra that was programmed with different sheets that would have little dots in them that would actually play a tune. So a very simple but very interesting aspect of that is that it is programmable. It would have a way of changing what songs were played. So even back in that time, very, very complex devices. And then the Canon of Proportions, written by Marcus Polio, was basically a book that explained how the human body is put together, which is how we get a lot of the ideas for current biomechanics that we use today. So that's a bunch of stuff in the past. How does that apply to what we're doing now? Is there anything new? Well, obviously things become increasingly interesting as computers come on the scene, but what other AD events can we talk about? Well, we see that even in recent years, whether it's in the United States or whether it was in Africa or other European continents or across the world, we've seen slaves and indentured servants. So that's obviously the initial kind of verbiage that we get from the original definition of robot. And so that's one way of doing that. Huron of Alexandria creates an Ellipoli, which was essentially a steam-powered rocket that would spin around, similar to the Pigeon, but you could change the speeds based, once again, on the different amounts of pressure that were going on. And then you also had him create what was essentially the first vending machine, so something that could vend different objects based on user input. So once again, early precursor to programmable things. And then Da Vinci had a wide variety of inventions, and we could go on and on about all the different things that he invented, but there's a number of them that were very autonomous in what they did in that sense because of the ability to program them. Even though we wouldn't call it programming like sitting down and typing code like we would consider today, but the ability to change the instructions that were fed into these devices was something that was critical in future development of computers and robots. So what about even more recently? Because none of these things really look like robots that we currently have. We think of robots as transformers or some of these cool things we see on television or whatever happens to be on Science Channel. Those are kind of the things we think about. So when we start looking at the 18th and 19th centuries, we start seeing some interesting things. Jacques de Vincennes created a thing called moving anatomy, where he basically took different physical creatures and tried to mimic them using machinery and parts. One of the things that he actually created was a duck that would quack and flap, and it would actually, if you fed food in its mouth, it'd actually mill up the food and quote-unquote excrete it, so that it was mimicking that biological process. Once again, kind of harkening towards some of the things that we see today with mobile insectronics and those kind of things. Joseph Jacquard created the automated loom, which was a programmable loom that would allow you to have different types of weaving occurring at different times based on what you were working on. Charles Babbage created the first mechanical calculator that could be programmed to accept different inputs and then have our first outputs, which was the precursor to what our current computers are. George Boole created a symbolic language for computers and is also known for Boolean logic. Nikola Tesla created the first remote-controlled boat, the Tesla coil, and a number of different amazing inventions as well. So we start to see the advancement of these interesting and very intriguing autonomous items that, even if they're remotely controlled or programmed and then do very simple things, are leading up towards the robots that we think of today. And then we have the 20th century.
In a simple villa on the outskirts of Bristol lives Dr. Gray Walter, a neurologist, who makes robots as a hobby. They are small, and he doesn't dress them up to look like men. He calls them tortoises, and so cunningly have their insides been designed that they respond to the stimuli of light and touch in a completely lifelike manner. Elsie, and she sees out of a photoelectric cell which rotates above her body. When light strikes the cell, driving and steering mechanism sends her hurrying towards it. But if she brushes against any object in her path, contacts are operated that turn the steering away, and so automatically she takes avoiding action.
So those were Gray Walter's turtles, and that was one of the first kind of interesting concepts of a actual physical robot. So where we come from his turtles and where are we at in the 20th century? Norbert Wiener was the father of cybernetics. He actually wrote a number of papers discussing how we could integrate human intelligence and mechanical devices. Isaac Asimov wrote a number of short stories, which later became a movie called I, Robot, but basically 3 laws of how we could actually protect humans from robots, and there actually is a flaw in the 3 laws, which is interesting to consider how robots would react and behave. And Alan Turing came up with a thing called the Turing test, which essentially determines whether or not an individual could be fooled by artificial intelligence programs. Some other things that have come along recently is Duvall and Engelberger created the first industrial robots that were used in manufacturing and assembly. MIT founded the Artificial Intelligence Lab, which has been coming up with a number of interesting robots and autonomously operated devices. The Unimate was the actual first robotic arm and was used in industrial assembly, so you see it immediately being incorporated into a wide application of business operations. Stanford creates a few different devices. Shaky, the first robot to actually know and react to its environment. The Stanford arm, the Stanford cart, the silver arm, and the cart redesign were all things that Stanford created that were all different robots that were able to interact with their environments in different ways. Freddy 2 was an arm that could take a heap of components and then assemble them in a organized fashion based on what they're supposed to be. So we're starting to see much more advanced things that are occurring here. So what about now, and where are we going from here? So more recent inventions that we see is Genghis, which was a robot that had an interesting gait as a 6-legged robot. So we see more insect mimicry in what was going on. Robot wars had pitted robots against each other, and we even see them making their way into toys such as the Furby and the Aibo. So where do we go? What are we going to do with this course? Well, the idea here is to start giving us an idea of what the future could be. We're seeing robots become involved in our toys, in our businesses, in our everyday lives. And so I think that more and more we're going to see robots integrated into our society in a number of different ways that help and assist humans in doing tasks that maybe are undesirable, but also maybe even dangerous for humans to do. Also in terms of future space exploration, and a number of other things, medicine. There's a number of fields that robots will start to continually expand into. So understanding the importance of robots, how to program them, designing, and that engineering process, even if you're not an engineer, may help you in the future in terms of interacting with people who are developing robots, as well as coming up with ideas for robots that may become great business ideas or business plans. So I hope that you understand at this point kind of where we started and where we are finishing and what the goal is of this course, which is essentially to give you an introduction to what robotics is, the engineering and programming processes, and get you kind of sparked into the interest of creating your own robots, whether they're just for play and hobby or if they solve a problem in the world that you could then turn into a business model. So in the future lectures, we're going to start talking about what programming language we're going to use, the engineering process, what that's all about, and actually start getting into our programming.